In this video, we'll be learning how to use the sine rule and the cosine rule. So in the previous video, we went through the derivation of the rules there from a right angle scaling triangles. So in this video, we'll be purely focusing on when to use which of these rules. All right. So as you remember, we said we always label the triangle sides according to the sides. So if you call this, it doesn't matter which letter you use, A, B, and C, as long as the capital goes opposite the little side. So capital A angle there. Make sure you use capital for angles and little letters opposite to that uh, angle to be corresponding letters. Okay, so they have to be matching. Otherwise, you're gonna get confused with the rules and you're going to make an error. So now we said I showed you the derivation of these rules here. Make sure you remember them and how you if you just remember one of these rules is enough for the rest. So okay, it's not that you have to remember six different formulas, it's just the same formula that's rearranged. Alright, so the general rule is that you're always going to, whether you like it or not, you're going to go down this. This is the easiest way to remember which rule to use. So this is called the decision path. Okay, in mathematics, uh, like if you're solving a problem, this is the easiest decision path I could find. Over 10 more than 10 years I've been teaching mathematics. So you ask yourself, is it a right angle triangle or not? If it's a right angle triangle, then you wouldn't even use sine rule, any of these rules above. You just go for straightforward either Pythagoras or sine trig ratios that we learned right at the beginning of this topic, which you should have learned in GCC, IGCC. If it's not a right angle triangle, it's a scaling triangle, you ask yourself, so you've come down this path. You ask yourself, do we know a side and its opposite angle? So in this case, we know the angle here is 38 and its opposite side is 8. Okay, so then if its the answer is a yes, we're going to go for the sine rule. So what do we do to figure out this angle missing b? Alright, so when you're going to use the sine rule and the angle is missing, it's best to use the one that is got sine on top of the fraction rather than sine at the bottom of the fraction. So I'm saying this is better here. This just has one more step of rearrangement if you're gonna use it. It's nothing wrong with that, but this is easier to use. So what we're gonna do quickly, we're gonna say, okay, this is capital A and that's going to be our little a here. So I'm just gonna substitute sine 38 here divided by 8 equals to, what's missing is sine b, but I know it's divided by 12, okay, because that's the opposite side. So instead of writing 12 here, I don't have a lot of room. I'm just gonna cross multiply both sides uh, by 12 here, rather than, so the 12 here are multiplied both sides by 12, so disappears. So now this is our the sign of b. Now we just got sign of b here. So b will be, let me just say that, uh, so to get rid of the sign, you're gonna have to use inverse sign. So inverse sign gets rid of this sign here. So this sign cancels with the inverse sign. So we're gonna have inverse sign, apply that to, put whatever inside the bracket, you're gonna have to write 12 times this fraction. Sine of 38 over 8. Make sure this 8 is outside the sine function. Don't divide 38 by 8. So don't confuse that. And make sure your calculator is in degree mode. Okay, many times students will be asking me, why is my answer wrong? Because if you got DEG on top of your calculator, things are all good. If you got RAD, that's radians. You don't want that. Okay, go to your settings, press shift, and uh, it's most of the time it's shift and uh, I don't know, the mode. Okay, setup. When you press shift and setup, you find how to change angles to degrees. Okay, so make sure you do that. Each calculator is different, so I can't teach everybody the correct way. But is the setup button or the mode button? Okay, look up for that to change degrees. Look for trigs and change it to degrees. All right, so you put this and this will give you the angle V. All right, so we just figuring same. We're just learning which rule to apply and how to use it. All right, so in this question we are looking for this little a there, and we've got these two sides embracing this angle here. All right, so now we don't. It's obviously a scaling triangle, and we don't have one side and its opposite. So we're gonna use the cosine rule. So how do we use it? Obviously, well, the cosine rule is straightforward. It's written here: a square equals to rb. Let's call it doesn't matter b or c. You can change them interchangeably. Uh, so we're gonna say b is 9. So 9 square plus 5 square minus 2 lots of 9 times 5 times cos of the angle 27. Alright, you're going to put that on your calculator, and actually you might as well put a square root to start with, because that's what we need to do at the beginning. You can do that and then square root the answer if you had pressed equal already. So just square root the answer and what's above, and you will get the correct number. Alright, I'm not going to put it on the calculator because I'm teaching you when to use which rule. So here, you've been given this triangle and you're looking for this angle here. It's a trick question. Pause the video, answer it. Alright, I hope you have. Uh, this is a right angle triangle, so you don't need to use any of these rules on this page. You just need to go for the simple trick. You call this adjacent, you call this hypotenuse, so it's going to be cos of capital B is going to be 5 over 9. So you're going to take cos inverse. You're going to say cos, shift cos and type in 5 divided by 9, and that will give you the angle. Alright, so then in this next question, we have the angle missing here, and we got all three sides of the triangle. So that's going to be our little a, because we call this angle capital A. This is B and C. Now I said B and C, you can swap them around, you can call this C and you call that B, doesn't matter, okay, in this. So you're going to say, ask yourself, do I know an angle and its opposite side? It's a scaling triangle that come down this path here. So because the answer here is no, we're going to go for cosine rule. Another way I remember the cosine rule, so every time I have all three sides of the triangle and I don't know uh, any of the angles, that's going to be cosine rule. The rearrangement of this cosine rule, alright, if you go through the rearrangement, you end up with this format where you have b square plus c square minus a square divided by 2 lots of bc. Alright, the a, capital A, tells me there's only little a squared subtracted in this top corner. Alright, so putting the numbers into that equation, we're gonna have 6 square plus 5 square minus 9 square divided by 2 lots of 6 times 5. Alright, and the last step, because we're looking for the angle A in degrees, is to take cos inverse of what's up here. Alright, just type that inside the cos inverse, or if you press answer here, if you press equal already, this will be stored as an answer. Then you can press on the next line in the calculator, just type shift cos to get this, and then if you find the answer key to on your calculator, put it there, it will give you what the answer should be. And then the outcome here will be the answer. Alright? This will be the answer. So what's coming next? Alright. In this next example, we've been asked to find the length, capital A. Alright, not an angle, the length. Alright, trick question. You don't need trigonometry, sine, cosine, tan at all. You're just gonna use what? That's easiest way is just use Pythagoras, okay? So don't confuse yourself. Don't go making long. Uh, you don't need to go the long methods, the long way. So you don't need any of these angles. So you're just gonna say the square root of 9 square minus 5 square will be 8. All right. So next question. You're going to ask yourself, is it right angle? No. So we're coming down here. You're going to ask yourself, do we have one side and its opposite angle? Or yes, we do. All right. So we're going to use the sine rule, and the angle missing is B. So one of these would do. All right. So if I've called that B here, so I'm now circled C, so that I'm gonna pretend that's the C and that's little c. So I'm gonna write uh, B sine of B, alright, divided by 9 equals to sine of 38 divided by 10, and cross multiplying by 9, I will have sine of B equals to 9 lots of sine 38 divided by 10, and last step is to take sine inverse. So sine inverse of 9 lots of sine 38 divided by 10. Now type that in your calculator, and if your calculator is in degree mode, you will get the right answer. And alright, so this next example, one more time. We've got three sides of the triangle, no angles. I know it's going to be the cosine rule. If you ask yourself, do I know this opposite side and opposite angle? The answer is no. That's why we're gonna use the cosine rule. Okay, and we are running out of time, so I'm not gonna write out what you need to do with this triangle. For this triangle, you ask yourself, a scaling triangle, yes. It's a scaling triangle, so we're down here. Ask yourself, yes. Do we know the opposite side and opposite angle? Yes. So we're gonna use the sine rule here. Now we call this. Um, we, we actually need to find this angle here. What's missing? What we can, the only thing we can do when you for using this sine rule here is to what you will have found is the angle opposite to this side here. Okay, so this is a trick question. What you then, let's say you figure this angle here, this angle C, all right, what you need to do as a last step, if you know two angles in a triangle, just you only need to remember is 180 minus 24 plus the angle C. So this is a very tricky question. Most students think that, oh, I'm going to use 9 and then 9 and it gives me B. No, no, this 9 is gonna when you substitute the values into this equation, it's gonna give you the angle opposite 9. Alright, so that's what you're gonna have to figure out. And the last step is to just say, well, once I know two angles in a triangle, the third one is a piece of cake to work out, isn't it? Because I used what I learned in primary school, 118 minus the two given angles. So, alright, here's the another example here. We got three sides of the triangle. So the smallest angle. Now they didn't even tell us which angle they want. You have to use your knowledge of and understanding of trigonometry. The smallest angle is opposite the smallest side. Now I see the smallest side is 4, so what they mean is figure out this angle here. Alright? And if you go down the decision path we learned, you ask yourself, do I know the opposite side and opposite angle of a scaling triangle? No. So you're gonna have to use that rule up there. But because we don't know the angle, all right, the if you rearrange this rule, is rearrangement is going to be cos of capital A equals to b square plus c square minus a square divided by 2bc, and we're going to call that little a, this b, 6 is b, and 5 is c. Alright, so you substitute those values here, you're going to get b square is 6 square plus 5 square minus 4 square divided by 2 lots of 6 times 5. And finally, because we want a, we're gonna take cos inverse of all this business. Alright, so you type this in your calculator, gonna go through the, you will get 41.4. Okay, so there are different ways of you could just substitute everything into that original equation and then try to solve it for what the unknown letter a here. That's nothing wrong with that. It's just that I like to just use my memory efficiently, figure out the uh, right formula is gonna look like so, and substitute into the right formula. That's my method, but some people just like to substitute everything into that equation and then solve it. Like it's, I think it is less likely, you're less likely to make an error with this kind of thing. Alright, so I think the answer is 41.4. Let's look at another example. Yes. So yeah, this other example is saying Coast Guard Station B is 8 kilometers on a bearing of 60 degrees from Coast Guard Station A. Ship C is 4.8 kilometers from bearing of. So you read these bearings as 18 degrees, okay, and that bearing is 60 degrees. There is a rule in maths for bearings. I don't know. Sailors used to have to use 3 digits no matter what. So this extra zero in front is because they have to have had three significant figures in their working out. I don't know why that is, but this is the rule for bearings. So you have to build up a picture here. Coast Guard Station B is 8 km on a bearing of 60 degrees. So here you draw a north line here and you say this angle has to be 60 degree. Okay, this is 60 degree, 8 kilometers, 8 kilometers on a bearing of 60 degree from A. So from A, okay, the word from A, where is it? Okay, from Coast Guard Station A. So when you're working, it's from A and B is up here, and this length, the dotted line, now I'm gonna call AB 8 kilometer. Alright, the picture looks like so, and the rest on a bearing of, so ship C away from A. Okay, so again, the 18 degree is measured with the same north line, but this time is somewhere up here, 18 degrees. Okay, so what's the this 18 and 60 tells us that this C is somewhere here, and the length we don't 4.8. We do know A to C is 4.8. Okay, so this is length A to C 4.8 and length A to B is 8 kilometers. So we've been asked to calculate distance C to B here. We want to know what is C to B. Now we need to know this angle uh, A, capital A, but this, let me draw it with a different color. We are looking for this particular purple angle here, alright? So we knew that the total angle was 60. We need to say 60 minus 18 is this purple angle here, A, CAB, okay? So angle CAB, if I put the hat on top of A, it should be clear we're looking for this purple angle. Is 60 minus 18, which is 42, alright? Is it? Yeah, 42 degrees. So now you can say I've got two sides embracing this angle here, so that's when we gonna use cos angle. If I have side angle side, this is the rule I'm learning that I know the 8 here, I know the 8, I know the 4.8, I have two sides and I know the angle between them. Alright, so this tells me go use the cosine rule. So how do I use it? I know I can I can just say I'm using this formula up here. So I'm gonna I'm gonna call this little a actually because that's capital A. It works out perfectly fine for us. So we're gonna call this A, but I'm gonna be lazy and put the square root there already on the calculations because now I know. Let's call this side B. Okay, I'll call that C there. So I'm gonna call this little c, and I'm gonna call 4.8 little b because I'll I'll put a B there, capital B there. So I might as well have them nice and neat matching each other. So 4.8 square plus little c is 8, so c square minus 2 lots of 4.8 times 8 times cos of the angle which I know is figured out it was 42. So as always I'm not having enough space to write everything there. There is a number 42 there in front of the cos. I'm just gonna write it here once again. So 2 lots of 4 times this is 4.8 times 8 cos 42. Alright, you put that on your calculator and you'll figure out the answer. Alright, so here's the picture, meter version of the picture, and it will come out to be, after you substitute the numbers, the square root of A is 5.47. Okay, so in this case, we have to use our knowledge and use what we know. So we've been told A in a triangle PQ is X. Alright, so the writing is asking us to figure out angle side X basically. So we know one side of the right this angle which is scaling and its opposite length. So we could use the sine rule, right? But the thing is we don't know any of these angles. So when you have two sides and the embracing angle between them, the cosine rule is the best to use. Alright? Because the, we don't know the other number here. We don't know these x's are not numbers, so sine rule don't apply. This is going to be cosine rule. So you're going to write uh, that cosine rule and just substitute the values into it. So let's write it. Little a, let's label 5 little a, and these two sides being c. So little a is going to be 5. We're going to have 5 square equals to x square plus x plus 2 square minus 2 lots of x times x plus 2 cos of 60. Now, luckily, cos of 60 is a half, so we can just replace cos 60 with a half and simplify this equation. You're going to have to multiply out the brackets, so it will be x squared plus 2x plus 4x plus 4 plus another x squared plus 2 lots of x squared plus 4x and so on. So that half, you multiply it out and you simplify to this equation because well, we are subtracting x squared and we are subtracting a 2x here. Start multiplying the half into this. That's why this x squared cancels that, and this minus 2x from 4x left us with a 2x. Alright, so now bringing 25 to the side of the equation, subtracting 25 and trying to factorize it or use quadratic formula, you're going to get x to be this answer. Why are we ignoring the other x? There is two answers there, but one of them is negative, and the side of the triangle in geometric terms is never going to be a negative value. Alright, so you want this equation, you only take the positive answer to be the correct answer. Once you know x, for the other side QR, you can figure just add 2 to it. All right, so I think this is the last example, yes. So it's been a long lecture, good practicing, and the sign rule, applying the sign rule in the next section should be easier.